So let's do an example of least common multiple, and we're going to do the shortcut way. You know that tree method we just learned? There is a reason why we learned it. It's so we can find the least common multiple a very short way. Instead of writing out all the multiples of that number, all the multiples of the next number, we can do it very quickly by doing the tree. Now, let's say we have three numbers: 14, 32, and 18. Tree method, break this apart. Be 2 and 7. 2 is a prime, 7 is a prime. 32 we can break apart. Do 16 and 2. 2 is a prime. 16 we can break apart. 2 and 8. And 4 and 2. 2 and 2. And these are all prime numbers right here. 18 we can break apart. Two numbers that equal 18 is 2 and 9. And we know 9 is not a prime because we can multiply it 3 and 3. So we have a 32 here, 18 here, and 14. What all these multiples, if we wrote all the multiples of 14, so you did 14 times 1, 14 times 2, 14 times 3, such, we'll have a long list of 14 multiples of 14, long list of multiples of 32, long list of 18. These are all prime numbers. What would the least number of common do they have with them? To figure this out, we look at each tree by itself. And they all have a 2 in it, but we're going to look at which one has the most 2's in it. We would say this one. Okay, since this has the most 2's, we count out all the 2's out of that one. 1, 2, 3, 4, 5. Okay, so we have 5 2's. 1, 2, 3, 4, 5. Okay. Now we look at the next number. What other primes do we have? We have 3. There's no other 3's here. We have 2 of those. Now if there was 3's in this one, there's only one 3, we would still take these 2 3's because this has more in this tree. Now, if this had more 3's in it, we would take those 3's. Say if this had 3 3's in it, we would take the 3 3's here and just forget those 3's there. So we have a 3 here and a 3 here. Now, what other primes do we have left? We have a 7. We only have one 7 out of all of this. Okay, and so why do we make a list of this? We have 2's here, 3's here, and a 7 here. Well, what you would do is you multiply them all out. So you go 2 times 2 times 2 times 2 times 2. That would equal 32. And then you take the 3's, 32 times 3 times 3, and then you times it by the 7. And you get once you times all those together, all those numbers together, you get 2016. This number right here is the LCM, the least common multiple out of all these multiples. So the multiples of all 14, all the multiples of 32, all the multiples of 18, out of all those, if you look at the list, you would have to go 2016 in order to find the least one. But there would probably be multiple common ones, but you'd have to hit the number 2016 before you would find it. So if you wanted to find what number, say 14, in order to reach this number, you just divide this by 14, and you would get 144. So the 144 multiple of 14 would equal 2000. Same thing with 32. This would be 2016 divided by 32, and you get 63. Now that's the 63rd number of the multiple of 32. Same thing with 18. If you took 2016 and divided by 18, you get 112. So this is the 112th number. So you'd have to make a really long list for each of them, and then you'd have to find out, oh, this is the lowest one that they have in common. Now, you just do this for all of them. What you do is you look for all the primes. You take the lowest prime first, and you look for each tree, which tree has the most in it. And so this one has the most 2's in it. So we're looking for all the 2's in each one. So we go, this has 1, 2, this has 5, this has 1. This has 5's, okay, we take all those 2's, we set them aside, and you ignore the other 2's. We don't count those anymore. Now you look for the next prime, that's the higher one. 3 would be the next one. So look through all this. This one has the most in it, so we just take those 2 3's, put them over here to your list. Now you look for all the rest of the 7. 7 would be the next one. So you put 7 in there. And then once you have got this group together, you ignore all the rest of the primes in each of the trees. And you multiply that all together, and you get the least common multiple. Alright, don't forget, I'm going to do another example in a second. And if you need also more examples, I will be posting those. Let's do one. Let's do a couple numbers. What do 12, 16, and 4 have in common with each other? Well, let's break 12 apart. 12 is 3 and 4. 4 is 2 and 2. Let's break 16 apart. 2 and 8, maybe? Yeah, that sounds good. This is 2 and 4. And this is 2 and 2. Okay, and 4 breaks into 2 and 2. This is very interesting. Now let's circle the primes for each one. There's a prime here, prime here. Now, what primes do we have? We have a 2 and a 3. Now we're going to take the tree that has the most of one kind. So how many 2's do we have in what tree? We have 2 here. No, that's not good. That's not the highest count. We have 1, 2, 3, 4 here. That's 4 2's in this one. That's probably the higher one for the 2's. This 2 here. So we have 4 2's. So 2, 2, 2, and 2. And we only have 1 3. So we'll put 3 at the end. So you multiply all these ones together. So 2 times 2 is 4. 2 times 4 times 2 is 8. And 8 times 2, 16. 16 times 3 is 48. All 3 numbers, they have a 48 in common. That's the least common multiple. So if you took the multiples of 12, multiples of 16, multiples of 4, the least one that they have would be 48. Thus concludes the end of this lesson. Lesson 1, factoring and least common multiples. If you need more examples, they'll be posted on my math manual underneath this video or underneath that page. Well, join us next time for lesson 2. Thank you for watching.